Heisenberg uncertainty principle state that we can't define a position of a particle with certainty, so we can make an approach to the possible position of the electron with the quantum number, which we have four quantum number. First is principal, angular, magnetic, and spin. The quantum number of the principal it shows to us about the shell level of the electron maybe exists. It's solved with the node n, which the number n is equal with 1, 2, 3, 4, and furthermore. So, to the other number, we can continue with the quantum number of angular, which is we can make a notation as L, and the number is 0, 1, 2, 3, 4, and the orbital is S, P, D, F, G, H. And we have a rule which is the L number. We may found the L number, it's from n mean 1, which is n. L is equal with n mean 1. So here we can have the magnetic quantum number is an interval of the negative of L number until the positive of L number. Spin number, it's only have two options, which is show you the negative half and positive half. Here the relation between quantum numbers and atomic the orbitals, which in the first shell, we only have the L value is 0. Remember that L is n minus 1. L is n minus 1. So if we have n equal with 1, the L number it's only just have 0, which 0 show to us that it's with 0 is an orbital s. With n equal with 2, the L number has the maximum n minus 1 is 1. So it also will have the 0 and 1. So in the second shell, we may have the orbital s and also orbital p. The ML or the magnetic, it shows to us the number of room, which shown by the interval of the value negative L until the positive L. If we have an L is equal with 1, so the value of this interval show to us how many room we have. Here, for example, the ML, if I have the given value of L, if the orbital is 1, it means that it's p orbital, so the possible ml is minus 1, 0, and plus 1. And also the possible for L equal with 2 is minus 2, minus 1, 0, plus, and plus 2. It means that in the d orbital, we may have 5 rooms. Here are the orientation of the orbital space, as we mentioned before, that the p orbital has 3 rooms, which is m equal with minus 1, m equal with 0, and m equal with plus 1. Different way with the d orbital, which it has 5 rooms, which means it show by the number of interval minus 2, minus 1, 0, plus 1, and plus 2. The Schrödinger wave equation also states the spin magnetic number. By the Hahn principle, we can't by the Hahn principle, we may found that electron only have two options in express this spin, minus half or plus half, which is the plus half. It's given for the arrow that goes to up, and when we want to give the number value of arrow that goes down, it gives minus half. Okay, For example, the Schrödinger wave equation, remember that the shell is equal to the value of n. The subshell is equal to the value of n and L. The orbital is equal to the value n, L, and ml. If I have the question, determine how many electrons can be accommodated in the one orbit. In the one orbital here, if we follow the Schrödinger wave equation, that there are four variable, which is the very uh, the most the most independent the most dependent the last number is spin. It's only just two possible. If we mix n, L, and ml fixed, so it we can show that the possible number for the spin, it also show the possible electron that may be occupied by the orbitals. How many orbitals in subshell 2p we can may occupy here that 2p. From 2p we can conclude that it has the n is equal with 2, means that it's in the second shell, and it has a subshell is p, which is the subshell of c of p is the number with L equal to 1. Remember that the ml of the magnetic quantum, the orbital, is interval between the L -1 or -1, 0, and +1. So it has three orbitals. It has three orbitals, and so like this picture. Next question is how many electrons in the 3D orbital can be accommodated here? When you see that the 3D orbital, if this is have n equal with 3 and the d is equal with the L2, and we may found that the L, if the L is 2, so the interval that may be found in this subshell is the orbital -2, -1, 0, +1, and +2. So we can occupy each orbital by 2 electrons. Total electron that could be found in this d orbital is 10 electrons.